Next, we are going to solve the assignment problem or Hungarian assignment problem, Hungarian method. First, check whether the number of rows is equal to the number of columns. If it is so, the assignment problem is said to be balanced. Then proceed step 1. If it is not balanced, then it should be balanced before applying the algorithm. The method balanced and go for further step. Step 1, subtract the smallest cost element of each row from all the elements in the row of given cost matrix. See that each row contains at least one zero. Step 2, subtract the smallest cost element of each column from all the elements in the column of the resulting cost matrix obtained by step 1. Step 3, assigning the zeros. Examine the rows successfully until a row with exactly one unmarked zero is found. Make an assignment to this single unmarked zero by encircling it. Cross all the other zeros in the column of this encircled zero. As this will not be considered for any future assignment. Continue this way until all the rows has been examined. Solution B. Examine the columns successfully until a column with exactly one unmarked zero is found. Make an assignment to this single unmarked zero by encircling it and cross any other zero in its row. Continue until all the columns have been examined. Step 4. Apply optimal test. Solution A. If each row and each column contain exactly one encircled zero, then the current assignment is optimal. Solution B. If at least one row or column is without an assignment, if there is at least one row, one column is without in one encircled zero, then the current assignment is not optimal. Go to step 5. Step 5. Cover all the zeros by drawing a minimum number of straight lines as follows. Subdivision A. Tick mark the rows that do not have assignment. Subdivision B. Tick mark the columns not already marked that have zeros in marked columns. Subdivision C. Tick mark the rows not already marked that have assignments in unmarked columns. Repeat step B and C until no more making is required. Draw lines through all unmarked rows and marked columns if the number of these lines is equal to the order of the matrix, then it is an optimal solution. Otherwise, not. Step 6. Determine the smallest cost element not covered by the straight lines. So subtract this smallest cost element from all uncovered elements and add this to all those elements which are lying in the intersection of these straight lines, and do not change the remaining elements which lie on the straight lines. Step 7. Repeat 1 to 6 until an optimum assignment is attained. In case the rows or columns contain more than one zero, encircle any unmarked zero arbitrarily and cross all other zeros. It is in its column or row. Proceed in this way until no zero is left unmarked or encircled. Note 2. The above assignment algorithm is only for minimization problems. Note 3. If the given assignment problem is of the maximization type, convert it to a minimization assignment problem by max z is equal to minus minimum of minus z, and multiply all the given cost elements by minus 1 in the cost matrix and then solve by assignment algorithm. Note 4. Sometimes a final cost matrix contains more than a required number of zeros at independent positions. This implies that there is more than one optimal solution. Multiple optimal solutions with the same optimum assignment cost. So now we solve the one example problem and how to solve assignment problem. So first we see the example. The given rows or columns first step, check whether the given problem is balanced or unbalanced. Number of rows, row 1, row 2, row 3, row 4, row 5. Number of columns, column 1, column 2, column 3, column 4, column 5. So number of rows is equal to number of columns. Number of rows is equal to number of columns. So the given assignment problem is balanced. First step 1, row minimum. Row minimum. The minimum value is 1. The minimum value subtract all the values. So 8 minus 1, 7. 4 minus 1, 3. 2 minus 1, 1. 6 minus 1, 5. 1 minus 1, 0. Next, second row, minimum value 0. So subtract the 0, all the elements in second row. So 0 minus 0, 0. 9 minus 0, 9. 5 minus 0, 5. 5 minus 0, 5. 4 minus 0, 4. Row 3, minimum value 3, 8, 9, 2, 6. Minimum, what is the minimum value? Minimum value is 2. So subtract this 2, the entire row 3 value. So 3 minus 2, 1. 8 minus 2, 6. 9 minus 2, 7. 2 minus 2, 0. 6 minus 2, 4. Fourth row, minimum value is 0. Subtract the all values in row 4. So 4 minus 4, 3 minus 0, 1 minus 0, 0 minus 0, 0, 3 minus 0, 3. Fifth row, minimum value is 5. So subtract the minimum value 5, all the elements in row 5. So 9 minus 5, 4, 5 minus 5, 0, 8 minus 5, 3, 9 minus 5, 4, 5 minus 5, 0. This is the row minimum. Next, we will take column minimum. Column minimum will consider row minimum. Column minimum. Column minimum. So last of time the row minimum value, take the column. So 0 is the first column minimum value. So subtract 7 minus 0, 0 minus 0, 1 minus 0, 1, 4 minus 0, 4, 4 minus 0, 4. Second column minimum value 0. So the entire column value repeated 3, 3 minus 0, 9 minus 0, 6 minus 0, 6, 3 minus 0, 3, 0 minus 0, 0. Third column minimum value 1. So 1 minus 1, 0, 5 minus 1, 4, 7 minus 1, 6, 1 minus 1, 0, 3 minus 1, 2. Next, fourth column, minimum value 0, 5 minus 0, 5, 5 minus 0, 5, 0 minus 0, 0, 0 minus 0, 0, 4 minus 0, 4. Fifth column, the minimum value is what? 0. So 0 minus 0, 0, 4 minus 0, 4, 4 minus 0, 4, 3 minus 0, 3, 0 minus 0, 0. So this is column minimum. This is the column minimum. Next step, assign the each row, each column. So write the column minimum value 7, 3, 0, 5, 0, 0, 9, 4, 5, 4, 1, 6, 6, 0, 4, 4, 3, 0, 0, 3, 4, 0, 2, 4, 0. So each row, each column having single 0. First I check the first row, assign a single 0. So I have two zeros. Next move on, second row. So second row having a single 0, assign the single 0. Column wise any 0 are in. So straight cross out that particular 0. Next second row, third row having a single 0. So assign row wise, assign third row, see the 1 0. So assign a single 0. Next column wise occur any 0, straight cross out the 0. Next, fourth row having a single zero. Fourth row having a single zero. So assign that zero. Any zero in column, so cross out into mark. Next, fifth row having two zeros. So no assign. Next, column wise assigning. A column wise single zero. Second column have a single zero. So assign that zero. Row wise again see the row wise any zero occur on the assigning row. So into mark the zero. Next, third column assign fourth column assign fifth column single zero. So fifth column assign single zero. So see the optimal each row, each column having a single zero assigned. Each row, each column, each row, each column having one zero assigning. So next, so finally the assignment schedule. The optimum, this is the A persons A, B, C, D, E, job 1, 2, 3, 4, 5. The optimum assignment schedule. The optimum assignment schedule. Assignment schedule is A2 5, B2 1, C2 4, D2 3, E2 2. So the assignment cost is the optimum or minimum assignment cost is the corresponding values of a given problem. 1 plus 0 plus 2 plus 1 plus 5. So the cost is 9 units of cost. So the given problem is the given problem. So assigned 0 value 1. Second assigned 0 second row first element, 0. Next, in the third row fourth element, 2. So that way return 2. Next, third element, fourth row third element 1, add 1. Fifth row assign 2. So 2 cost is 5. So add this value is 1 plus 0 plus 2 plus 1 plus 5. So 9. So minimum cost is 9. First step, assignment problem. Given assignment problem is balanced, number of rows, number of columns is uh, equal, then the given assignment problem is balanced. So n cross n matrix. First step, row minimum, row value, first row minimum value 1, so subtract all the values in row 1. Second row 0, 0, subtract all the elements in second row. Third row minimum value 2, 2, subtract all the values row 3. Fourth row minimum value 0, 0, subtract row 4. Minimum value 5, fifth row, subtract 5 row elements. So get row minimum. Next, find column minimum. Column minimum, First column minimum value 0, second column minimum value 0, there is no changes. Third column minimum value 1, so the 1 subtract each element of column 3. Column 4 minimum value 0 and column 5 minimum value 0, there is no change in column minimum. Next, write the same values in column minimum. Assign each row, each column single 0. Each row, each column assigning single 0. So completed the each row, each column assigning a single 0. So the optimum schedule is A to 5. A person assign a job 5. B person assign job 1. C person assign job 4. D person assign job 3. E assign 2. So the optimum minimum cost is 9 units.